Sri Sathya Loka Seva Gurukulam online classes. We've been learning differentiation of trigonometric functions. So in the previous video, we have learned the derivatives of all trigonometric ratios. Not only that, we've also solved few using the first principle of differentiation. Please go back to the previous video if you have not watched. Take down the formulae before you move on to this. So now, in this video, we are going to differentiate more trigonometric functions for more better practice. Find the derivative of each of the following functions with respect to x. We have two functions here. Let's solve one by one. Now, the first function is y is equal to tan root of x. So, y is equal to tan root of x is the first function that we have been given. So, we can very well see that it's a composition of functions. The outermost function is a trigonometric function. The inner function is a power function. That is, a variable is raised to a power. So now, how do we differentiate this? We always start from the differentiating the outermost function, right? So when I differentiate this with respect to x, what do I get? Dy by dx. So that is equal to, when tan x is differentiated, you get, when tan x is differentiated with respect to x, d tan x by dx is nothing but secant square x. So now my outermost function is a tangent, a tan function. So when I differentiate that, I should get secant square of the angle, that is root x, into, what does the chain rule say? Now we have to differentiate the inner function. What is the inner function? That is root x. That is nothing but x power half. It's a power function. We need to bring the power down. Half x power half minus 1. And on differentiation of the base, that is x, we get 1. So now let's rewrite this. This is secant square root x into x power minus half by 2 into 1. You can skip it. Now, always remember, put the algebraic function first. So there's a combination. It's a product of two different functions. In such cases, always put the algebraic function first before the trigonometric function. So now, x power minus half by 2. And the second rule that we've seen is, we should always express in positive powers. So we'll bring the x to the denominator to make the power positive, and then write the trigonometric function. So this can be rewritten as 1 by 2 root x secant square root x, or secant square root x by 2 root x. So this is how we use chain rule to differentiate the one that has been given to us. Always remember, every part of the function needs to be differentiated, starting from the outermost function, moving inward. Do not skip any part, or do not differentiate two parts at the same time, simultaneously. Every part has to be differentiated separately and has to be multiplied to each other. So this is the solution that you get. The first step usually is the differentiation, after which you will rearrange and express it in the right way. Now, moving on to the next function. Y is equal to pi cot 3x. Now, pi, as I've told you, is a constant. Its value approximately in fraction is 22 by 7. It's an irrational number. So approximate decimal value is 3.14. So it's a constant. So now let's differentiate this with respect to x. So what do we get? dy by dx. So we all know that when a constant coefficient is there, it will remain as it is on only the function, the variable function that is attached to it is getting differentiated. So pi remains just like pi. And now I'm just supposed to differentiate cot 3x. So what do I get when I differentiate cot x? When I differentiate cot x, I get minus cosecant square x. When I differentiate cot x with respect to x, I get cosecant square, minus cosecant square x. Now, my outer function is a trigonometric function and my inner function, the argument, is a polynomial or an algebraic function, right? So now, how do I differentiate this? Again, I need to use the chain rule. Unless and until it is just x there, whenever the angle is another function, you need to use the chain rule. Please do not forget it. So the outer function is the trigonometric function. First, let's differentiate that. So I'll get minus cosecant square 3x. I should not differentiate 3x in the same step because I'm only differentiating the outer function here, that is the cot x. So that on differentiation gives me cosecant square, the angle value, that is 3x here, into, now the inner function is 3x. So now I will differentiate that. When I differentiate 3x, I get 3. So I hope you all understand the chain rule properly. Now, let's rearrange this. The negative minus the constant coefficients to be put first, and then the trigonometric function. So this is your dy by dx. I hope you understand. In case of doubts, please go back, put the video in pause, take down the solution, listen to the explanation again and again, because these are very, very, very important steps that you need to follow. If these simple steps are followed the right way, differentiation is going to be very easy, trust me. Let's move on to the next question. Find the derivative of each of the following functions, wherein this is the function that is given to us. Now, as soon as I look into the function, it has trigonometric functions in it, but it has a numerator and a denominator. It's a fraction that's given to us. Whenever there is a function on the numerator and on the denominator, we very well know that we have to use v by u by v, sorry. That is the quotient rule. How do we do that? We need to use the quotient rule here. So what do we do? Whenever it's a fraction that is supposed to be differentiated, y dash will be, the denominator will be kept unaltered, numerator will be differentiated, minus numerator will be kept unaltered, and the denominator will get differentiated, and the denominator will be squared onto the denominator of the derivative. This to differentiate. So the outer function, that's first thing is, we have to use u by v. Let's see. Now differentiating with respect to x, what do we get? F dash of x is equal to, so I have to keep the denominator unaltered, sin x minus cos x, into, differentiate the numerator. Now what is the numerator? It is sin x plus cos x. It is a sum of two trigonometric functions. So sum of functions, when you differentiate it, how do you differentiate? You'll differentiate the first function plus the second function, right? You differentiate each function and again sum it up. So now sin x on differentiation gives me cos x, and cos x on differentiation gives me minus sin x. So sin x plus cos x is going to be a sum of cos x and minus sin x, that is nothing but cos x minus sin x. Minus, now what do? We keep the Numerator unaltered now. So I'm going to keep it as sin x plus cos x and differentiate the denominator, that is sin x minus cos x. Again, it is a difference of two functions. So sin x on differentiation gives me cos x and cos x on differentiation gives me minus sin x. So it's minus sin x, that is nothing but plus sin x, right? I hope you understand this. Be very careful with the signs. Divided by, the denominator is going to be squared. So my differentiation is over, but of course you all know that we have to simplify and express it in this simplified form. Now how do I do this? This is sin x minus cos x and this is cos x minus sin x. So what do I do is, I want to write it the same way so that I can multiply easily. Yeah. So what do I do? Let me open it up and multiply, or you take the minus sign outside and this will become minus of sin x minus cos x the whole square. If you don't understand this, multiply inside and open the brackets. I'll teach you that if that looks easier for you. So this is sin x cos x minus sin square x minus cos square x plus sin x cos x. This is sin x plus cos x the whole square. So that becomes minus sin square x plus cos square x plus 2 sin x cos x divided by sin x minus cos x the whole square. So now let's simplify. You have sin x plus cos x plus sin x plus cos x, 2 sin x cos x. So you have minus sin square x minus cos square x plus 2 sin x cos x. I'm going to open this bracket up, so changing the signs. So minus sin square x minus cos square x minus 2 sin x cos x by sin x minus cos x the whole square. So this can be rewritten as, this and this gets cancelled out, minus 2 sin square x minus 2 cos square x by sin x minus cos x the whole square. So this can be written as minus 2 can be taken out, sin square x plus cos square x by sin x minus cos x the whole square. I'm sure you all know sin square x plus cos square x gives you 1. So this can be rewritten as minus 2 by sin x plus cos x the whole square. So this is what we get when we differentiate f of x is equal to sin x plus cos x by sin x minus cos x. Here we have used the quotient rule to differentiate. Here it says f of x is equal to 1 plus x cos x. So it's very, very clear that it is a product of two functions. One is an algebraic function, another one is a trigonometric function. First function and the second function. So we know how to differentiate the product using the product rule. If y is equal to product of two functions, then dy by dx is equal to, first one remains unaltered, second one getting differentiated, plus second one keeping unaltered and differentiating the first one and summing up both. So this is how we differentiate product of two functions. So let's move ahead. So differentiating with respect to x, what do I get? F dash of x is equal to, the first function, I'm going to keep it unaltered. When I differentiate cos x, it's going to be minus sin x. Please learn all your formulas thoroughly so that it's not a difficulty for you to differentiate simple functions. Plus, the second function, that's a trigonometric function, remains unaltered, and I'm going to differentiate 1 plus x square. It's a polynomial, sum of two algebraic functions. 1 when on differentiation gives me 0, and x square on differentiation gives me 2x. So now my thing is to rewrite it. Let me put the minus first. Algebraic function, then the trigonometric function. Similarly, in the second term, algebraic function, then the trigonometric function. Now, is it the final answer? Still, I can rewrite it. Always see to it that the negative term does not come first. Rearrange, put the positive term first, then the negative term. So this is my solution. Then I differentiate 1 plus x square into cos x. Easy, easy. So here f of x is sine 2x into cos 3x. Again, it's of the form u, v, first and the second function. So we are going to use the product rule to differentiate. So differentiating with respect to x, we have f dash of x is equal to, so what do I suggest is that pause the video here, you solve it simultaneously, then go back to the solution and see how right you are. So now sine 2x to be kept unaltered, cos 3x to be differentiated. Here we have two functions. One is the trigonometric function and the angle value is a function in itself. It's 3x. It's a complex function. It's a polynomial. So now we are going to use chain rule to differentiate it. So first, the outermost function is a trigonometric function. Cos 3x, cos x on differentiation gives me minus sin x. So cos 3x on differentiation will give me minus sin 3x. At this stage, I shouldn't be writing minus 3 sin x. Minus 3 sin x, which will go wrong. You shouldn't be differentiating all at once. Step by step, the outermost trigonometric function to be differentiated first, and then the inner function, that's 3x, to be differentiated. You get 3. Plus cos 3x to be kept unaltered. Now sine 2x on differentiation. Now the outer function is sine. See, but if the angle value is just x and we are going to differentiate with respect to x, it is simple. You just differentiate sine x and you get a cos x. But the moment it is a compound angle or a multiple angle, you need to consider it as a function in itself and use the chain rule to differentiate. Now sine 2x on differentiation will give me cos 2x into 2x on differentiation will give me 2. So I'm using the chain rule. First differentiating the outer function, then moving inwards. Now I need to rewrite it. So I can write it as minus 3 sine 2x cos 3x plus 2 cos 3x. Sorry, it's minus 3 sine 2x sine 3x plus 2 cos 3x cos 2x. So now can I rewrite this? Yes, the positive term first. So 2 cos 3x cos 2x minus 3 sine 2x sine 3x. I can leave it here. This will be my derivative. So here my f of x is equal to root of sine 3x. Any guesses? What is the outermost function? Yeah, it's a power function. So we need to use the power law and then use the chain rule to put step-by-step differentiation and multiplying all the derivatives together, right? So now differentiating with respect to x. So I have f dash of x If f of x is given, my derivative is f dash of x. If y is given, then the derivative with respect to x is going to be dy by dx is equal to. Now let me rewrite this so that I can easily use the power rule without any confusion. This is what it means, right? So the outer function is a power function. So we will first use the power rule. Half sine 3x, the whole power, half minus 1. Moving on to the inner function. That's a trigonometric function. The next function, that is the base. So sine 3x on differentiation gives me cos 3x. Now the innermost function, that's an algebraic function, again has to be differentiated. 3x on differentiation gives me 3. So now the rewriting starts. I put the numerical coefficient first, so I'll put it as 3 by 2. Now this is nothing but sine 3x, the whole power minus half. So I need to make it into positive power. So let me write the numerator first and then the denominator with positive power turned into a square root sign. So this is how I'm going to express my final answer. Now let's move on into the next question. Find the derivative of the following function. Now again, so that it is easy for me to start my differentiation, we'll discuss the complete question, the whole raised to the power half. The first, looking at it, you're able to find that it is a power function, the outermost function, right? So let me give you two methods for the same question. So differentiating with respect to x. Dy by dx is equal to, first let's use the power rule, bring the power down, subtract 1 from the power, the whole power minus half, right? Into, now the next function is of the form u by v. So now we need to differentiate, keeping the denominator a constant, differentiating the numerator. So secant x plus tan x, what do you get on differentiation? Secant x on differentiation gives you secant x tan x, plus tan x on differentiation gives you secant square x, minus the numerator kept unaltered, the denominator on differentiation, secant x again gives you secant x tan x, minus tan x gives you minus secant square x, divided by secant x minus tan x the whole square. Now let's start simplifying this. This is 1 by 2, this is power half, minus half, so I'll just take the reciprocal and make it positive and put it under the root. And here now I need to simplify. I can very well see that secant x is a common term out here. So I will write it as secant x minus tan x into secant x plus, so secant x taken out, you will have tan x plus secant x or secant x plus tan x, however you want, you can write it. Minus, again here secant x common is taken out, so you have secant x plus tan x into tan x minus secant x the whole divided by secant x minus tan x the whole square. So this again can be rewritten as 1 by 2 into root of secant x minus tan x divided by secant x plus tan x into secant x minus tan x into secant x plus tan x gives you secant square x minus tan square x into secant x minus, here it is tan x minus secant x into tan x plus secant x. So you have secant x into tan square x minus secant square x divided by secant x minus tan x the whole square. Observe carefully. What is secant square x minus tan square x? 1 by cos square x minus sin square x by cos square x. That is 1 minus cos square sin square x by cos square x, which is going to give me 1. So this is equal to 1. This you have learnt it in your junior grades. So let's apply the identity here to get, let me use, so I have half root of secant x minus tan x this is 1 into secant x, this is minus 1 into minus secant x, so this is secant x plus secant x by secant x plus tan x the whole square. So this is equal to 1 by 2 root of secant x minus tan x by secant x plus tan x into 2 secant x, because secant x plus secant x gives you 2 secant x by secant x plus tan x the whole square. So this 2 gets cancelled out. You can write it as secant x first and then the square root term secant x plus minus tan x, divided by, this is inside the root again, so you can put this in together. So this whole square so this 2 and this 2 gets cancelled out. So you get secant x into root of secant x minus tan x divided by, this is secant x plus tan x the whole power half into secant x plus tan x the whole square. So you know the rules of exponents. When the base is same, the powers needs to be added when you multiply it. So that becomes secant x plus tan x the whole power half plus 2. This is whole power half, this is 2. So you add up both the powers. So half plus 2 gives you 5 by 2. So here I simplify and write it this way. So this is my final answer. Go through the solution once again for your easy understanding. So we've just done step by step, that's it. First we have differentiated using the power rule. Then we have differentiated using the u by v. Then we have simplified and written it in the most simplified form. So what's the next method that you can do? You can rewrite y and then go ahead differentiating. That is, you can multiply and divide by the conjugate. Multiply by the conjugate of the denominator, So you multiply by secant x plus tan x, both to the numerator and to the denominator. So what do you get? You get secant x plus tan x the whole square on the numerator divided by secant square x minus tan square x. So this is nothing but 1. So we have root of secant x plus tan x the whole square out of the root, it comes out as secant x plus tan x is your y. Isn't this easy to differentiate now? So your dy by dx is going to be, when you differentiate secant x, you get secant x tan x plus tan x on differentiation gives you secant square x. Now how do you go ahead? You take secant x common outside, you get tan x plus secant x. So this is your final derivative. This just takes few steps. So the moment you look at the sum, you need to know what to apply when. So in the previous method, it took us one full slide to solve the problem, right? But here if you see 1, 2, 3 steps, we have arrived at the derivative. So looking at the problem, you need to practice so much that it should come to your mind what method to use. The moment you look into secant x minus tan x on the denominator, it should strike you that secant square x minus tan square x is going to give you 1. So just multiply by the conjugate and simplify it and express the function itself in a different form so that it is easy for you to differentiate and get the derivative. So could we move on? Now find the derivative of the following functions at the indicated points. So this point we are supposed to find the derivative. For that, first we need to find the derivative of the given function. So let's differentiate with respect to y. Sorry, with respect to x. So what do we get? Y on differentiation gives us dy by dx is equal to. Now looking at the question, we know that it is of the form u by v. There's a function on the numerator and one on the denominator. So we'll use the quotient rule, keeping the denominator unaltered, differentiating the numerator. 1 plus sin x, how do we differentiate? 1 differentiating 1 gives us 0. Sin x on differentiation gives us cos x. Minus 1 plus cos x, that's the numerator, will be kept unaltered. And the denominator, that's cos x on differentiation, gives you minus sin x. By the denominator is getting squared. So now my differentiation is done. I need to rewrite this. So cos x into cos x gives me cos square x. Minus 1 into minus sin x gives me plus sin x. Minus sin x into minus sin x. This minus of sin x into minus sin x will give me plus sin square x. Divided by cos square x. Here you can might be change the sign like this and then also you can multiply. It's absolutely up to your convenience. But please don't make mistakes in the signs. Okay, so now let's simplify this. Here we have cos square x plus sin square x. So you get 1. Cos square x plus sin square x gives you 1 plus sin x by cos square x. So this is the derivative you get when you differentiate y is equal to 1 plus sin x by cos x. Now, we are supposed to find the derivative at the indicated point. What is the indicated point? It says x is equal to pi by 4. X is equal to pi by 4. What is pi by 4 equivalent value in degrees? It is 45 degrees. How do we do that? A quick conversion into degrees is equal to into 180 by pi. So this is into 45 when you simplify it. So it's 45 degrees. If it is convenient for you in degrees, just convert it and then find the equivalent trigonometric ratio value. So this is 1 plus, now we are supposed to find dy by dx at x is equal to pi by 4. So let's substitute the x value. It becomes 1 plus sine pi by 4 by cos square pi by 4. As I told you, pi by 4 is 45. 1 plus sine 45 is 1 by root 2. By cos square 45 is 1 by root 2 the whole square. So this is 1 plus 1 by root 2 by 1 by 2. So how do we simplify this? These are very, very normal addition and subtraction. Take LCM. Root 2 will be the LCM. You have root 2 plus 1 by root 2. And you multiply by the reciprocal of the denominator. You get 2 into 2. So on simplification, you can cancel this out with root 2. And you will get the answer as root 2 into root 2 plus 1. Or 2 plus root 2 is your dy by dx value at x is equal to pi by 4. So this is the way you need to solve. Okay. Now the next question. It says y is equal to root of tan x plus root of tan x plus root of tan x plus etc. till infinity. Now we need to show that 2y minus 1 dy by dx is equal to secant square x. So how do we do it? We can see that on the right hand side the entire term is in under root, right? So first let's square both terms and see what happens. Squaring both sides. As I told you, I'm going to rewrite y according to my convenience and then go about differentiating. So we've seen that first we differentiate and then we simplify and express it in a way. And then secondly, what we do, we make changes and express y, the given function, in a convenient way and then go about differentiating. Few questions back, we felt that expressing y in a convenient way and then differentiating it gave us a quicker solution. So here also we are going to do that only. So let's square both sides and write y square is equal to, when I square it, the root goes off. So I have tan x plus root of, only the outermost root goes off. So the inside term remains the same. Now, if you look at this, don't you think this term and this term are the same? Yeah, it is. It is nothing but your y. Root of tan x plus root of tan x plus root of tan x plus etc. till infinity. Since it's an infinite term, it's one and the same. So this can be rewritten as y square is equal to tan x plus y. This is nothing but your y. So now it looks easier without the root and all that to differentiate, right? So now we will differentiate it. So differentiating with respect to x, what do we get? We have 2y dy by dx is equal to secant square x plus y, always on differentiation gives you dy by dx. Right? While when you differentiate with respect to x, you get dy by dx. Okay. Now I'm supposed to prove this. On my left hand side, I have all the dy by dx terms, right? I've differentiated. Now I just need to rewrite it. I'll bring all dy by dx to one side. So I have 2y dy by dx minus dy by dx is equal to secant square x. So whenever show that such type of problems are there, you need to rewrite and express it in the given way, as per the question. Okay. So now here again I can take dy by dx common outside. I get dy by dx into 2y minus 1, right? When I factorize it, that's what I get. So this is equal to secant square x, or this implies 2y minus 1 into dy by dx. You all know that multiplication is commutative. So when I multiply this to this or this to this, all the same. So I rewrite it the way I'm asked to express, and this is the answer. So hence proved. Easy, isn't it? So you just need to find the pattern out and rewrite the function and then go about differentiating. So let's move on to the next question. Now, it says cos y is equal to x cos of a plus y. We are supposed to prove that dy by dx is equal to cos square a plus y by sin a. This is not explicitly written. Usually, y is equal to something in terms of x is given. But here, if you see, this is called as an implicit function. Y and x are put together. So now what we can do is, we can take all y's to one side and all x to one side, write it explicitly and then go about differentiating so that it's a little easier for us in this case. Let's see how we are going to do it. So I'm going to write this as cos y divided by cos of a plus y. Because here also I have y. I'm going to bring it to one side. I can't bring this alone because it's part of a function. I'm going to bring the function itself to this side and write it like this. Only x on the other side. Now I'm going to go about differentiating. Let's see, I'm going to differentiate with respect to x. So what happens? How do I differentiate? I use u by v here because its outermost function is a quotient function. So we need to use the quotient rule of differentiating. So I'm going to keep the denominator as it is. Differentiate the numerator, that is cos y. Cos y on differentiation gives you minus sin y, and y on differentiation gives you dy by dx. So the outermost function is a trigonometric function and the innermost function is y, and you're differentiating it with respect to x. So you need to put a dy by dx here. Minus, keep the numerator a constant, differentiate the denominator. Cos of a plus y on differentiation gives you minus. So let's make this plus here because I get a negative term now. Minus sin of a plus y. So now this minus, I have made this plus, so we'll take this out. Now a plus y on differentiation gives you dy by dx again because a is an arbitrary constant. It's denoted by a variable, but a, b, c are constants in that particular situation. So a gets nullified into 0 and y on differentiation gives you dy by dx divided by cos of a plus y the whole square, right? So this is equal to, on the right hand side when I differentiate x with respect to x, I get 1. So now I just need to rewrite this. I have to take dy by dx out because I have to apparently find that one only, right? So let me take dy by dx out. So what do I have? I'll put the positive term first, cos y sin of a plus y minus cos of a plus y into sin y divided by cos of a plus y the whole square, or I can write it as cos square a plus y also. This is equal to 1. Now look at this. This is cos a sin b minus cos b sin a. So what is this formula? This identity represents sine of a minus b. So what is my a? This is my a, this is my b. So let's go ahead doing that. So, just a minute. It is nothing. So sine of a minus b is equal to sine a cos b minus cos a sin b. So this is also of the same form. Sine of something into cos of something minus cos of something into sine of something, right? So my a is this and my b is this. If you compare with this, you will get to know that we are using this identity here. So this sine a minus b. So now I have dy by dx into sine of A is nothing but A plus y minus B is again y divided by cos square A plus y equal to 1. So now y gets cancelled out. So I'm supposed to find my dy by dx. I'm taking all the other terms to the other side, which is when multiplied goes to the other side as division or the reciprocal. 1 into this, that is cos square A plus y divided by sine A. That is what I'm supposed to prove. So have you all understood? So first we've rewritten this as an explicit function. Y is on one side, x on the other side. Then we have differentiated. So please be thorough with such identities which will be of great use. You need to know where to rewrite what and in how, what way you will replace it for you to arrive at the answer. So these identities are important, algebraic identities, trigonometric identities that you have learned so far. And then how to rewrite and start comes over practice. That's all in this video. Hope you all understood. Sai Ram.